Hello everyone, welcome back to Instructive Academy. So far, we have learned lot many things in the chapter force, like units of forces, basic concepts of forces, some different types of motions, contact forces, non-contact contact forces, and many different formulas. And today we are back with a new session, and in this session we're gonna be learning what exactly moment of force and equilibrium is. So stay tuned with the session and focus on the topic which we are going to learn today. So let's begin with the translation motion. Let's go word to the definition. So it says, when a force acts on a stationary rigid body which is free to move, the body starts moving in the straight path in the direction of the force. This is called as the linear or translation motion. Let me explain you with a practical example in front of you. So let's take this pencil. If this is a stationary object means free in space. It's free, no forces applied to this object. So if what I'm going to do right now is I'm going to apply a force on this body. If I apply force to this body in this way, this body is gonna slide. That means if I'm applying force to a stationary rigid body which is free to move, the body free to move means no any pivot point attached to this object. The body starts to move in the straight path in the direction of the force. That means I'm applying force in which direction, students? In this direction, right? So I apply force to the body in this direction. The body starts to move further. Okay, so that's what the point which they are trying to explain with the help of this definition, that is translation motion. So we have done with this. Let's put a tick mark to it. Let's move further with the next point, the rotational motion. It goes, so the definition of the rotation motion goes like this. So what does the definition say? It says, if the body is pivoted at a point, the force applied on the body at a suitable point rotates the body about the axis passing through the pivoted point. This is called as rotational motion. So students, let me explain you with this topic also with an example. Let's consider this pencil only for the example. Imagine for a period of time, I'm putting this aside. Imagine this as an stationary object. We used this object as for the translation motion also for explaining the example. We applied a force in this position, right? In this position. So the pencil moved further. In the same way, if if the definition was, if the body is pivoted at a point, the force applied on the body at a suitable point rotates the body about the axis passing through the pivoted point. That means if a body is pivoted to a point, that means, example, if I'm considering this point as pivoted, that means this point is stationary, not stationary, this point is fixed. The other points on the body are stationary, they can move. So if I apply force to the body now with a fixed point on the body, what will happen? Let's see. Okay, so what we are able to observe here, we observe that the body was in this position and now we apply force at the same point where we applied before. The body didn't move further. Instead, it starts to move in a particular rotation. That means if a body is pivoted at a point and a force applied on the body at a suitable point rotates the body through the axis passing through it. That means this becomes the axis, this becomes the radius of the body, and that radius the body will move. So this is a rotational motion, because rotation is, you can see the rotation, right? Rotating, the body is rotating. This is rotation, right? This is rotation. In the same way, the particular example is explained. So let's move further. Since we have completed these two examples, let's next coming up topic is moment of force or torque. So what is this? So students, remember, torque, what is torque exactly? Let me tell you with an example, considering the example before. Like if like we took an example of pencil, right? Consider this is a pencil, right? We pivoted the point of a pencil at a particular point O. We applied force F over at point A. Okay, this pencil starts rotating, and that was called as rotational motion. Correct? Rotational motion. But but what is torque then? Torque is the force used or applied, I mean the amount of force used or applied on the body to move the body, to rotate the body in its own axis. That force is called as torque. That applied force is called as torque. So the definition will be as the same as the rotational motion. But remember, as the topic changes, even the factors affecting the particular topic also changes. So there are only two factors affecting the moment of force or the torque. That is the magnitude of the force applied. That means how much amount of force am you applying on the object to make it rotate. The first one, this is it, and the second one is the distance of the applied force from the pivot point. That means this point A, this the distance between the point A and point O. Let's consider it as D. That's the distance. So these two factors definitely affect the turning of the body. What if that means they want to explain, just explain this thing, that if the force is applied not at point A, if we apply force at point B, what will happen? The same force. Will it rotate more easily? Will it rotate like just like before, or will it rotate a bit slower than before? That's what the thing is, the factors affecting the turning of a body. So we were discussing about the torque right up till now. So let's also know what exactly the moment of force is. We understood that this body is pivoted at a point O and we are applying force, just imagine, at a point A. So distance between the point O and point A is D. That means the force applied and the pivoted point distance is point A, I mean the distance D units. So what is moment of force? Moment of force is the product of the applied force and the distance between the applied force point and the pivot point. That means F into T. Remember students, I am boxing this equation because it's very important, and even starting the equation, please do remember the equation, that is the moment of force. So let's proceed. If we go on defining the moment of force, that is the moment of force is the product of the magnitude of the applied force and the distance between the applied force and the pivot point. So we have done. Let's proceed now. I'm sorry students, before proceeding, let me tell you one important thing. We discussed torque, right? Remember, torque is a vector quantity. Why it is a vector quantity? Because it have one direction. We are applying force in this direction or this direction or this direction. And for any type of your like unit, if it has magnitude and direction, then it is a vector quantity. So I've written over here. Okay, let's proceed to the next topic. There's also one important point we missed, that is, it depends upon the force. We discussed that point, but let me highlight that point once again. It depends upon the magnitude of force and the distance from the pivot point which is applied to rotate the body. That means if we what happens if we apply a x amount of force, x newton of force at point A, how easily the body rotates, and what if we apply x newton of force at point B, and let's see how the body rotates. So the next topic is exactly how will the body move if the body is pivoted at a point. Definitely it gonna be like move like in two directions, either in anti-clockwise or either in clockwise. So as we discussed, so we were discussing many of the, like in all the examples with the help of this pencil, either it will move in this direction or it will move in this direction. That means anti-clockwise or clockwise. So we have done with the direction also. Let's start with the units of the moment of force. Okay. Students, let me tell you one thing. We have discussed this units of moment of forces in the previous sessions. So if you're not aware of that, I would suggest go and check that video before. I'll be providing the link in the description as well and in the I button. So click on the I button. So you'll be getting that video first, and after looking at that video, you'll be able to understand this session more clearly. So exactly it says, so you'll be getting the answer as this. Okay, let's move on with the next topic by getting some examples of the moment of force. Since we have discussed lots of examples in this session, so let's consider an example, an important example of shutting a door. So let's take example of the door, shutting the door. Imagine the door moves in this direction or this direction, right? That means the axis will be in this way and the pivot point will be the corner of the door. So imagine we have the handle of the door, normal doors here itself, right? So imagine if we just push the handle a bit inside, somewhere like here, will you be able to grab the door, grab the handle of the door and pull the door easier? No, it becomes difficult for us. So, as according to the equation and the problem, like of the problem statement, if we apply force towards the, like not near to the pivot point, the force exerted will be less and the motion will be more. So we have done with this example also. Let's go to the one more example. So this example is a bit interesting. We considered this example, right, before, pencil example, and the pivot point was over here. Imagine the pivot point is over here. Okay, so if we apply a force over here, what will happen? The body will start to rotate in its own axis. This is also an example, and do you remember where do we see this example? We see this example in the steering wheel. We apply force over here to take turn right, and this will start rotating this motion. So students, we have completed few of the topics in this session. Stay tuned with the session. We will be completing more topics in the further sessions. Thank you so much. If you like the video, do like, share and subscribe.